All right, we're live. How's it going, everybody? 3 people watching. We'll get started. I'm just gonna record. We got a lot of stuff in the house. We got a good fridge, yeah. And so you'll hear a lot of noise in the background. But let's just get started. Fifth grade. Let's start with fifth grade. You guys will be doing a. It's weird. I'm skipping one lesson to go to the virtual lab, but technically the virtual lab is more related to the first part than the second. You guys will be doing basically an introduction to the geological time scale. Basically, if you were in class, let's see if I still have it here. You would have gotten one of these guys, which you will get most likely in seventh grade again when we study the age of the Earth and all that. But basically, you're going to study about ancient creatures, ancient life forms that used to exist here on planet Earth. For example, dinosaurs used to be here a long time ago, like 65 million years ago, but they're not the, you could say, first creatures on Earth. And no, as much though I like to say man was the first creature, technically it's like sea cells or something, like small little things that barely survive. They're extinct now, but over the course of history, you've had different things like you have 4 major eras, 3 where life has existed, 1 where no life existed. So the Protozoic age is basically the era before all this, all life came to be on planet Earth, whether it be plants or cellular. Like maybe there was some pre life era, but there wasn't that many. The main ones we're going to study about the Paleozoic, Mesozoic, and Cenozoic. Paleozoic is the first era of life. So you have a lot of sea creatures, a lot of plants. That's what mostly dominated the age for a good like 250 million years or so. Then you had the Mesozoic, which is or Middle Age. That was mostly run by dinosaurs, lizards, reptiles. That usually runs anywhere from 250 million years ago to 65 million years ago, so under 200. So a little bit under 200 years. And then from 65 to now, it's the Cenozoic or the current age. Mammals, so creatures like humans, cows, anything that gave live birth, that's the dominant species now on planet Earth. I'm not to say that we're outnumbered by plants, but it's the one that you can say this is the main thing that separates them all. Like every era has plants, but whoever's like you said, the dominant animal, that's what it's named after. So one of the things, so that's basically what you're going to cover. You're going to cover a little bit about the early ages. You will have a lab on Tuesday or Wednesday of next week going over this, but just let you know, that's there. Yeah, that's the fridge. It's a huge fridge. Um, but let's move on with sixth grade. Sixth grade, acids and bases. I mentioned it a little bit earlier. What an acid and basis is basically the amount of, you could say, electrons and how it interacts with other elements. For example, when you add acid to a water, it kind of becomes a little bit acidic, the water. Um, it gives like a stinging sensation. Not stinging like, oh, it's poking me, more like it just feels a little bit. While bases add more of a soapy texture to it. That's most soaps are made of bases, base elements. Well, more like you could say citric stuff, like lemon and stuff. That's more acid. And to an extent, battery. Battery is acidic. The chemicals there are acidic. Some properties of acids and base. Acids are sour to the taste. If you were to try, like again, a lemon, it's sour. Bases feel more bitter. If that makes any sense. So, like, God forbid you ate soap, but that's what a base tastes like mostly. Bases also are slippery and they can conduct electricity compared to acids. Acids can barely. Acids can well. Acids can conduct electricity, but not. Or they can start electricity, start currents. While bases do it more for the opposite. Like they kind of store battery, they store energy, while acids store energy. Um, what else do we have to talk about? Acids and bases, because you guys will be doing. I'm seeing if I get a comment, but no. You guys will be doing a bunch of stuff related to that. Neutralization. That means you want to try to get not too acidic, not too basic. The most neutral thing on planet Earth is water. Water has an even amount. I'm making you watch a brain pop video right now, even though technically I should have given you the next chapter, but I kind of want to use it now to introduce you to it. The pH scale. That's how we measure how acidic or basic something is. It's a scale from 1 through 14. We'll talk about the strips in a virtual lab next time, but just letting you know that usually bases have a number of a pH scale of 1 to 6, and you don't need to know what pH stands for. Just the measurement tool. You'll learn more about it in high school because it's kind of complex. Well, bases are anywhere from 8 to 14, and what's between 1 to 14? 7. 7, and water is neutral. Usually, in order to make an acid more neutral, you have to add a base so it could drop. Same thing with the opposite for a base. If you want to make it more neutral, you have to add some acid to it. And usually, cleaning supplies are the main source of bases, while acids are more for like stinging and killing stuff, like most bacteria. Too much acid's bad, but also too much of a base is bad. There's a reason why you're not supposed to like put a like for example baking soda. If you like eat baking soda raw, it's bad for your health because it's super basic. It's super basic. It'll mess with your body. Your body's a mixture. Hi. It's a mixture between an acid and a base. So if you put too much acid in your body, you don't feel well. Well, if you put too much base in your body, again, your body doesn't feel well. It doesn't like it. It likes to stay neutral at a 7. I think our body's like somewhere between a 6.5 and a 7, and also like a 7.5, but that's super rare. But yeah, those are acids and bases. I'll talk a little bit more about the pH scale on Friday and go a little bit over how to read it and how to use the pH strip, which unfortunately we can't use because well we're not in the class we would have done in the lab. With 7th and 8th grade, I'll just quickly summarize your stuff related to section 2. You'll be doing assessment today. You will start part 3 to Friday, I think. Let me double check. Friday, yeah. And you're just gonna go over like cellular structure, like the organelles inside. But before we go there, just remember atoms are basically the building blocks of all living objects. Also, the people that just arrived, that's a fridge. You bought a fridge. Um, Lipids, again, know what those are: proteins, carbohydrate, nucleic acid. Nucleic acid, remember, those are the main ingredients inside DNA. Remember, there's only 4 letters. We technically would have gone over this a little bit more when we got to like heredity and stuff like that, but I don't think we'll have time. But in heredity, you do have 4 nucleic acids, and just know that each one's paired up some way. But the way they're chained together, like A, B, B, C, or A, G, G, T, C, G, T, like that's one code for something. Usually they're paired by 3s, but they're usually always, like, for example, A always goes to G, or A always goes to T, G always goes to C. And they're just abbreviations for the actual, like, long word version of themselves. Know that with cellular life, it's made of molecules, compounds. Know that. Uh, know how the membrane works. That's about it, really. But yeah, this is kind of a short section. Kind of went over most majority of it on Monday, but hey, if you want to watch the replay, just watch the replay. Anyway, I'm gonna head off and help him with the fridge. So I hope you guys are having a good time. We're almost at the end game. We got 2 weeks left. I think I'll have a stream most likely Friday again. If something happens and I can't do it Friday, I'll let you guys know on the on Cool Classroom. But yeah. Anyway, guys, take care, and I'll see you guys next time. Ciao.